Good afternoon to all of you. I am Dr. A. Patnaik from IIT Roorkee. Today the topic is the role of soft computing techniques in mobile communication engineering problems. I started working on this particular area in around 95, and there is a group of people who are thinking that this research in soft computing technique, as far as you are doing research in core soft computing area, it is good, but the application area is just for fascination purpose they are doing that, but it is not the fact, and you can solve lot of unsolved problems in engineering, starting from civil engineering up to communication computer science engineering. You can solve a lot of problems in engineering using soft computing techniques. Let me first touch what is a soft computing technique. It consists of it is not a single method, it consists of a number of methods that imitate human intelligence with the goal of creating tools provided with some human-like capabilities. That means when you are making soft computing tools, it actually is having a capability which the human beings are having, such like learning, reasoning, and decision making. And Professor Jade, he has given a specific definition for soft computing technique. I'm not going to that. Now, if you see what is the difference between soft computing technique and the hard one, it exploits the given tolerance of imprecision, partial truth, and uncertainty for a particular problem. See, if you see real class problems, we are not always going to the specific kind of measurement techniques. For example, I need, suppose I fixed the AC temperature, suppose 15 degree. Now if it is 15.5 degree, absolutely there is no problem for me. So you are not going for pinpoint measurements. Whereas in hard computing, it strives for exactness as well as for full truth. In soft computing, inductive reasoning plays a larger role. What do you mean by that? Inductive reasoning is if you have certain facts, basing on that you can predict the future of that. But it doesn't play any role in case of hard computing. Let us see one example how you are going to park a car. I am not going to do this particular measurements to park my car. Only the problem I have to solve is that I have to slowly bake the car so that I can avoid any obstacle. That is the purpose. If I am doing that, my problem is solved. I am not going to do all these particular measurements. So these are the key soft computing areas: neural network techniques, genetic algorithm, bacteria fuzzy system, particle swarm application, and right now people are working on all of these topics in every engineering kind of problem. You can find the application of these particular techniques. But today I am not going to discuss the application of all these techniques. I will focus on application of neural network techniques for this mobile communication engineering problem. So I will focus on a brief about this. What is the role of neural network in case of these problems, and some specific problem in case of mobile communication engineering. Then I will go for what are the rest possible problems available. See, these are some of the advantages of using soft computing technique or in specific neural network technique is that it gives an alternative to closed form expressions. If for some specific problem, if you are not able to find out a closed form solution, then this can give you a solution, this particular technique. neural network techniques are neuroscience inspired computational tools. What does it mean? That how a particular human brain works or animal brain works, depending on that, looking to that particular effect, people have devised the artificial neuron structure, and by combining a number of artificial neurons, they have formed a neural network, so that that can imitate the human brain or animal brain. And to implement these networks, what you need is they can learn a particular thing. That means you can expose the network with a certain kind of environment. So after training or after learning, the neural network will adapt to that particular environment. So it learns from experience. That is what is called as the training. Generalizes from previous example to new ones. If you have trained your network with certain kind of thing, after training it can solve similar kind of problems. Why it solves that kind of problems? Because it abstracts essential characteristics from the input containing irrelevant data. That means you have exposed your network with certain kind of environment, so that it can work in that environment. There are certain features. I'm not going to the details of that, but one thing to know is that to implement a neural network, you need some sample data value of that particular environment. To give you a brief idea what is a neural network, although in biological neural network structure, neurons are placed in a haphazard manner, but in case of artificial neural network, the neurons are placed in the form of layers, and each layer contains a specific number of neurons, and the computation starts from the input layer and it goes layer by layer, and you are finding out the output, right? That means what you are exactly doing here is you are forming a mapping between your inputs and the outputs. But here is y1 is a function of these three parameters, y2 is also a function of these three parameters, and simultaneously you can find out the value of y1 and y2 if you have certain sample values of data. Now what do you mean by training? Because in the last slide that I showed you, each of the neurons are connected, and each connection has certain weight value. To find out the optimized value of the weights for those specific training data is what is known as training. That means if you have for your input parameter x, if the desired output is d, and if you are using a neural network for x, if it is giving you y, the purpose is to minimize this difference with respect to the weight values. It's a multi-layer neural network. The another diagrammatical representation showing what do you mean by this training of neural network. You are actually changing the weight values, that is the variable in case of a neural network. Now how it is used in case of this mobile communication engineering, and for specific how it is used for smart antenna modeling. Now if you recall Professor Paul's lecture in the last yesterday, he was pointing out something to smart structure or reconfigurable structures, right? Now what exactly is that? What are smart antennas? A smart antenna, it consists of an array of elements or array of antennas combined with signal processing in both space and time. Now antenna, if you see an antenna, it's a metallic object, it's a passive object, right? Now how it becomes smart? The background signal processing technique that are placing is actually makes the antenna smart, right? So these systems of antennas include a large number of techniques that attempt to enhance the received signal. That means by changing the background signal processing technique, you can enhance the received signal capability of your antenna. Suppress all interfering signals. You can suppress the interfering signals by changing the background scenario. and you can increase the capacity. You see this particular diagram, if this is the desired user, then the main beam of the antenna is directed towards the specific user, that is the desired user, whereas the interfering signal, if it is coming from that side in that particular direction, you are having a null. That means your antenna is not radiating or receiving any signal from that particular direction, right? So by changing the background, the signal processing behind the antenna, you can relocate or reorient your radiation pattern of the antenna. Now what is the job of this your smart antenna is? First it finds out in which particular direction your desired signal is coming. So see this blue lines and these red lines. Now first your antenna will find out the direction of arrival, right? After finding out direction of arrival, it will form the beam in that particular direction, right? So one is, first you have to find out the direction of arrival, second is the beam forming technique, right? Both of these things, it is the job of the smart antenna technology. Now see, these red lines are the interferers and the blue lines are for users. Now after forming the beam, see the main lobe is towards one of the user, and all the lobes are towards the user, whereas the nulls are towards the interferer, right? So how actually this smart antenna forms the beam or a specific lobe in the desired direction? So what it does, because you are using a number of elements or number of arrays, so each of these array you are feeding, you are giving a feeding to each of these arrays. So feeding means you are exciting the element with certain amplitude and certain phase, right? So by changing this amplitude and phase, or in other words we can say that by changing the weight value of these particular connections, you can vary the beam of the array. No need to physically orient the antenna. Suppose for example, take a example of a horn antenna. Suppose my transmitter is on this side, receiver on that side. I have to face my horn towards that particular direction. But when you are using an array, no need to physically orient your antenna. This background signal processing, by changing the excitation of different elements, the beam pattern can change. A smart antenna helps in improving the system performance by increasing channel capacity and spectrum efficiency. It increases the channel capacity and spectrum efficiency also. Extending range coverage, steering multiple beams to track many mobiles. Simultaneously, it can track many mobiles in a specific area because it gives main lobes or lobes in the specific direction and nulls in the interfering directions. It reducing any delay state multipath fading co-channel interference, that means the interference in case of smart antennas is very less. And when you are considering the mobile communication technology, the main drawback of that particular technology is co-channel interference. What is that? That means two cells that are using the same frequency. That is what is known as co-channel frequency. So if you are using a smart antenna, see this particular user and this user, they are using the same frequency, but because this particular user is inside this base station, so that user is getting a main beam from the antenna. But although this user is using the same frequency, but he is getting a null. That means you are not getting any signal from this particular interferer. For this user, this is an interferer. Now after determining, first the system has to find out the angle of arrival. Now the problem is in a cellular communication system, this has to be maintained in a real-time fashion, right? Because the system has to find out the angle of arrival, and at the same time it has to form a beam in the specific direction. So it is a completely real-time operation. So the available methods that are used still today, they are in use, but see, in some cases you are finding that if you are using your cell phone at this particular point, you are getting a very good signal, but if you are moving 5 feet away from this point, you are not getting a signal. What is the reason? That means you are not getting signal from your base station, right? So because the available methods are not suitable for real-time application, that's why we are going for this neural network technique. There are two different types of smart antenna technology are there. One is a switched beam, another is adaptive system. Switched beam, it has a fixed number of lobes, but in adaptive array you can change the main lobe. The switched beam technique. Now this is the basics of smart antenna technology. You have number of area of antennas, right? And after this low noise amplifier analog to this converter, you are actually doing the digital signal processing behind the antenna, so that the antenna is radiating in specific directions and it is not radiating in some other directions. So the basic purpose is, to form the beam in real time, the system has to find out the specific weight values that has to be applied to all these antennas, so that it will radiate in a specific direction. That is the job. These are the methods available, right? When you are looking at mathematically, it gives a your antenna is receiving a incident waveform. After certain processing, you are multiplying this with the weight values, and finally you are combining that, and this yk is used to find out the direction of arrival, right? If you are getting number of signals, it will find out the direction of arrival of the specific user, right? And after finding out the direction of arrival, the same these W's will be used to find out to keep the beam pattern of the antenna, right? So first thing is to find out yk, from that find out the direction of arrival. Then the second step is, for beam forming, you have to find out a set of optimized weight values. Those two particular things can be solved by neural network technique for real-time operation, right? For whenever you are using a neural network technique, you need some sample data, and after getting this signal, you do the sample data processing here, and that has been that is applied to the input layer of the this neural network, and after post processing you are finding out the output. Now what exactly you are finding out the output? From these outputs you are finding out the theta values. What is the angle of arrival with respect to a specific alignment? You are finding out that theta value. I am not going to the details of this mathematics, right? So basically you are finding out this theta value as the output of the neural network. So train a network offline, right? That means by before training you collect some sample values of data by taking data in different angles, find out the corresponding output value. Using those sample values of data, train a network in offline mode, and after training that particular network can be used as in online mode. Now how to, because suppose I want to scale a particular area minus 90 degree to plus 90 degree, right? Now because it is a very large area, so I can't, for data generation I can take all the angles at 1 degree difference or 2 degree difference, because if you are taking in that way, your data base will become a huge one, right? So what is the solution for that is you divide the whole range into number of sub ranges. What is this one? Minus 90 to minus 80, minus 8 to minus 70. That is, each one is now of 10 degree your antenna is scanning that 10 degree. So for that 10 degree, you find out your data values. So this particular sub-region will find out whether a desired user is there or not in this region. Similarly, this particular subsection will find out whether a desired user is there or not. Right? After that, all these subsections can find out the individual users, whether a single user is there or a number of users are there in that particular region. It can find out. These are results compared with the desired response. I'm not going to this is experimental setup that we did to create the data value. Right? Now in the beamforming phase, what you are doing, your output is the weight values, right? Because depending on the weight value, that means depending on the excitation to each of the elements on the array, your antenna will radiate in a specific direction, or it will give you a null in a specific direction. So in the second phase, actually you are finding out these weight values. So these are the results for beamforming. Antenna array beamforming energy is directed towards a desired direction. These are the desired direction, and because there is an interference coming from this side, so you are having a null in this direction. Some of the results of this experiment. Right? So because we need real-time operation in case of mobile communication, so that's why going for the possible methods available, instead of going in that way, you can use the neural network technique so that real-time operation is possible. Now some other application is in this particular area is fault finding in large antenna arrays. Now suppose a satellite, it uses antenna arrays which contains 1,000 number of elements, right? Now suppose due to some reason that particular array, in that array suppose some particular faults are created, right? Now you can't change that particular antenna because that is not accessible, right? So how, now again there are two different problems. First thing is, from the base station itself, you have to find out which particular antennas are not working in that array. Second thing is that how to change the weight values or the excitation of the antennas which are in working condition, so that the same radiation pattern can be restored. That we have to do from the base station itself, right? So we tried to solve that one. So it's just a linear array containing 16 elements. Now if all the elements are working correctly, then you are getting a very directed beam pattern, right? Now if suppose the fifth element is not working, a specific element is not working, what you are getting is the side lobes try to raise, right? If two of the elements are not working, you are getting more number of side lobes. What does it mean? That means there is some kind of relationship between the number of fault elements on that array and the radiation pattern, right? So we try to find out that particular relationship, because mathematically there is no relationship between these two. You can't find out a formula for that, right? So we tried to use the neural network technique and solve this particular problem. If you are giving a cross section of that radiation pattern, then your network output, neural network, is giving you the specific outputs. It is giving you the output the 0.500. What does it mean? That means the fifth element is not working if this is the radiation pattern. If this is the faulty radiation pattern, then the fifth element is not working. Similarly for other patterns, 2 elements are not working in this case, 3 elements are not working in this case, right? So on the base station itself, by observing the faulty radiation pattern of the antenna, you can find out which particular elements are not working. Then accordingly you have to choose the excitation of the other elements. That is the problem that is open. You can tackle that particular problem. Second thing is Professor Paul was addressing the reconfigurable antenna systems. What is a reconfigurable antenna? Single antenna with number of elements. Now think for a car. Suppose a car is using a TV system, a GPS system, a mobile system. So for each of the system I need a specific antenna. If my car is using n number of different kind of systems, I need n antennas on the vehicle, right? But now your people are finding out a single antenna can operate at all those particular frequency. Only thing, the user has to tune that one, like tuning of a radio system. What is the concept is, say this is the typical reconfigurable antenna system. Suppose this is the these are using microstrip patches. I am not going to this particular layers. Now I want to use the GPS system and the mobile system. That means my antenna, reconfigurable antenna, should operate at those two particular frequencies only, right? So I have to connect these particular elements in a specific way so that it will radiate or work in those two particular frequencies. So how to connect those elements so that my antenna, or I can use those two operations, right? So that is another problem that can be solved by this neural network technique. Only thing, you have to find out specific sample data values, right? This problem is yet to be solved, and you can use the same technique to find out a input output relationship so that you can solve this particular problem, right? So the point is, I am not going to this conclusion. I have not made a conclusion side. Now whenever you are finding out an optimization problem or a regression problem in any kind of engineering, you can go for the soft computing approach. That is the conclusion.